So generally, if someone asks you what is data mining and how it's different than traditional programming, many of you probably have taken some courses in programming, right? They are familiar, they like coding, sitting long hours before the PC, writing codes, or maybe doing freelancer or whatever. So now the question comes in and say, okay, well, how data mining or machine learning is different than the traditional concept of programming. So here today we're going to talk about it and explain in more details. So firstly, the idea behind data mining is that the ability to automatically discovering useful information. We'll see that in soon how that means, but you can keep in mind when we talk about data mining or machine learning, that means we are talking about giving the ability to the machine, to the PC to do prediction. So keep in mind when we talk about data mining or machine learning is the capability to predict the outcome or future observation. So what does observation means? So try to take notes. These are important. When I say observation, that means a new case. Let's say I want to ask my PC about the stock price for tomorrow. This is future, right? And the observation is the case. I'm talking about tomorrow. Or let's say today, maybe how the stock price will end at the end of the day. So I give some details. So far, how the stock is working or how is the stock is performing, what are the factors. Then I produce to the PC. Then I'm waiting the outcome. So the observation is the case. Observation is like a row inside the table. Now I'm giving you all these details. Tell me what is the outcome. This is the observation. Okay, or maybe I'd like to predict the price of a house. Let's say I have built a program that is able to predict about the house price. Okay, so then I found a particular house. I need to predict the price of that house. That particular house is the observation. That particular house is the case that I'm looking to find the outcome of it for the future, for the house price, for the car price. So observation simply means the case, that particular house, that particular car I'm working on to predict its price. So you have built an application or a system or model, we usually say, to predict the car prices. So I collect many prices for many cars and all the other factors, whether it's sedan or not, the capacity of the engine, and etc. All this information I have collected. And this information, we call it historical information, historical data. Why we call it historical? Because simply it has already happened, already took place in the past. So what I mean exactly when I say historical, that means I got information about other cars have already been sold out. So I got all the information about the type of the car, the brand, the model, the year of production, as I said, the capacity of the engine, and etc. and etc. and etc. Plus, I got how much it was sold for. So this is called historical data. So now I take all these data, I bring it to my model or to my application, nice, and I tell or I program, I do build up my model based on this historical data. And don't forget the car price is there because it's history. It's already sold. I'm not looking for future observation yet. This is history. It's already in the past, gone. So I introduce it to my model. My model will try to learn, to find something that can be learned from data to help me to do future prediction. This is the idea. So I bring historical data. Again, history, keep it in mind. That means something already happened, gone in the past. I'm not going to predict it. This is not the idea because it's history in the past, gone. So I take this data, I introduce it to my model or to my application, and then that model will be able to predict for future observation. So again, the observation, let's say I built a model for car price prediction. That means the observation, let's say I'm going to sell this car. So it hasn't been sold yet. I'm going to sell it. So I need to predict based on all these historical data. I'm going to predict the price for this car. So I tell my model, okay, here are the information about my car. This is the brand. This is the model of production, the year of production, the model, the capacity of engine, blah, blah, blah. And then I tell my model, tell me the prediction for my car. How much would it cost, or how much I can sell it for? And then someone else also has defined it, saying it's the field of study that gives computers the ability to learn without being explicitly programmed. Now, this might be confusing. How without being explicitly programmed? This might be a little confusing phrase. So if you let's say you want to develop an application, if we're talking about computers, right? Developing application, whatever language you are using, what do? Right? You usually go study the problem and then define the way that you can perform. Let's say you want to calculate the area of rectangle. So you go straight away, you write the equation, you put the input in there, you substitute them. If you want to request the input from the user, you do so, and then you get the output. That's it, straightforward. Now here, it's not the same way. If we're talking, for example, about prediction, so how do you get the equation? Right? How you get the equation? Can you search on the internet, for example, looking for the equation of car prediction, like the rectangle, and then just bring it there from there and put it on the machine, write it, substitute numbers? Of course not. We cannot, right? We cannot go to Google and write, please, I need the car prediction equation, or I need house prediction equation, like the rectangle, straight away. Just you go substitute and you get it. It's not that way. And actually for two reasons, it's not that way, because it has so many factors included. And it also may differ from one country to another, from one region to another. There are many things. There are so many factors included. It's not that much easy like you think calculating the area of rectangle. Now, how to find this equation, the suitable equation, let's say, that fits for a particular region, for a country, and etc. So how do you do it? Right? So we need some way to teach the PC how to find it, how to get it into it. Now, when we need to do that, we need to apply, for example, some sort of statistics in order to find something, in order to build a model that can understand or can actually do prediction. So this is why it says is not explicitly programmed. You need to do some other fields. You need to add in statistics, for example. You need to teach the application how to find that equation. So it's not explicitly there, right? There's a learning stage. You need to teach it itself to the PC in order to be able to have future prediction. It's not like the equation. You don't need to teach the PC, for example, how to calculate the area, do you? Right? The equation is there. Just you bring it to the PC, substitute, and that's it. But here it's not the same. We need to find a way to teach the PC to learn. So this is why it says the ability to learn without being explicitly programmed. I cannot tell the PC coming or while I'm developing, well, this is the equation for car prediction, for example. It's not that way. So I cannot say it. I cannot tell it because I don't have it. So I don't have the ability to explicitly program, write a program to the PC to tell him or to tell the PC how to predict the car or the house price. I cannot. So this is why it says without being explicitly programmed. I cannot. Actually, I cannot. Right? So I need to teach him how to learn. Then he can use this algorithm, how to learn, to find it himself, to find that equation. So again, we don't have the ability to tell the PC explicitly how to do future prediction, but I can teach him to learn how to learn. How I only introduce him the historical data, and I tell him, well, this is the data, and here how you can learn. Try to find something. This is the way of learning. And then the PC will start to learn, apply that algorithm, and hopefully he can find that mysterious equation that would use it to apply later to find you the future prediction. Now, if you tell me about house prediction, for example, it might be easier, right? Because you can ask about the house prices of this area right? See the number of rooms, etc., the location near to the bus station or near to the train station, etc. And you can guess by yourself. You don't need to build a program, right? Maybe someone will tell you, come on, you're wasting your time. It's easy. Of course, you can argue or you can say two things. First, moving or transferring this knowledge to the PC is not easy as you think, right? We need how you tell the PC. If you write a program without applying machine learning or data mining, what do you tell the PC? If the price in this range, then maybe the future price will be like this. Sorry, if the number of rooms is like this, then the future is like this. Then if the location is near, if the area or the area, I mean, the size of the house is big or room small, and etc. So there you would write so many things, and things will get even more complicated, more than you can imagine. As I said, sometimes the case you are working on may include 100 or 1,000 of factors. So how you can write that? If you need to use if condition, for example, inside your application to predict, it will be so much hectic work, or even sometimes if it's very complex, it's impossible. It's impossible because if it's complex, we wish or we hope that the machine learning will be able to do it, to come up with the solution. So how would be the traditional way of programming? Okay, here is also another definition, is a computer program is said to learn from experience E. So now we keep this in mind, experience. What does experience means? With respect to some task T and some performance measure P. If its performance on T, which is the task, as measured by P, improves with experience E. So simply, let's substitute these mysterious words, experience, task, performance. So experience simply is the historic data. So hopefully, as we were saying, a computer program is set to learn from historical data, the training data. So in precise, experience means here the training data that you introduce to the PC, to the model to learn. With respect to some task, you have a particular objective task to do. Let's say house prediction. This is your task. And some performance measure P. Now, this is something we need to keep in mind. If we have some training data and we build a model, is that enough? Just that's it. We say, okay, I gathered historical data about the house prices and I build up my model to predict. Then the first thing I would say maybe, or someone can ask, how good your model is, right? How good? Have you tested it? Have you tried really to predict for house prices in your area, or based on the application you are building, maybe in certain region or not, right? So this is, we would ask naturally how good your model is. So you start testing. So the point is we need some way to measure how good or how bad our model is. So here comes the element performance measure, P, because this can be used as indicator while we are teaching the PC or the building up the model. So we can use that performance measure and tell the model or see how good or how bad. So if he is bad, then we need to keep learning, right? We still need to learn more or to find maybe some other algorithm. Maybe this algorithm doesn't fit well to the data, or maybe the data has problems. So there are so many things we need to start dive and dig into if the performance is bad. So the performance is like the indicator to see, to measure how good or how bad we are performing. Okay, so again, we have three elements: experience, which is the training data that we introduce to the model, to the application that we are working on. With respect to some task, of course, we have some objective we are doing. We're just introducing any data. That data is meant historical data for houses, because the task is we need to predict the future price for another house is meant to be sold, for example, right? So again, experience is training data. Task is the task simply you are working on, and some performance measure. We need that element, as I said, to measure how good or how bad our model is performing. Okay, so if its performance on T as measured by P improves with experience E. So of course, because this data the model will use it to learn to improve the performance, right, on that particular task. Now, this is another definition. So you see there are many definitions actually, and this from Microsoft. So data mining is also called predictive analytics, and machine learning use well-researched statistical principle to discover patterns in your data. Again, this is why we are using statistical principles. Like, for example, we will see later when we work on regression, we are actually applying statistics. But why we are doing regression? Because we need to find that mysterious equation I just was talking about earlier, right? So this is why it's not explicitly programmed. We're going to another field. We're going to statistics. And then we're trying to find that mysterious equation using statistics that hopefully when we apply for future observations, okay, so it's good we start using these terms, future observations or future cases, to have a good prediction. So you see the word good, that means the performance. The performance is good for my model. That means is able to predict very well. Or it may be very bad. So later we're going to see what are the challenges that we may encounter when we come to data mining or machine learning. Okay, so keep in mind, not explicitly programmed. We are using some other way. We're only teaching the PC how to learn. We applying statistical principles, right, to discover some patterns inside our data that he can use later to predict for future. So we're going actually in totally another way than the traditional way of programming. We are applying statistics. For example, we are using logistic regression or linear regression. So we're coming later to explain about what these terms mean. But the idea is we are applying statistical principles to discover some patterns. So if I'm talking about linear regression, that means I'm looking for the mysterious equation. That equation will help me to predict for future price. So once I find this equation, I can just substitute, like similar to the case of area, calculating the area for let's say a rectangle. I just substitute inside that equation and it will give me y, because y is the important thing that I'm after, right? Is the value, the future observation or the future outcome for a particular observation.